Hello and welcome. So here we're looking at some examples of quadratic modeling that you're going to use in your problem set 6 problems. So again, these are not exactly like the problems you're using, but it's kind of the strategies and equations that you're going to use in general for those problems. So let's look at this first example. So a drainage canal has a cross-section in the shape of a parabola. Suppose that the canal is 10 feet deep and 20 feet wide at the top if the water depth in the ditch is 5 feet. How wide is the surface of the water in the ditch? Alright, so this is a reasonable picture of what this scenario is. So we have this canal, and the shape of it is parabolic. So this is a parabola. So it says that we have, it's 10 foot deep and 20 feet across at the top. Alright, so a good place, you want to place a coordinate system. So imposing a coordinate system, probably this is a good place for the y-axis. Okay. And now the x-axis, where to put the origin? You could put the origin here, or you could put the origin at the bottom. Okay. I'm choosing to put the origin at the vertex of the parabola. Having the vertex at 0, 0 makes the equation a little bit, simpler. Okay. Alright, so let's find the equation of this parabola. So we have y equals ax minus h squared plus k. So let's start with the vertex form of a parabola. The vertex is at 0, 0. So that's your h and your k. So we have y equals ax squared. That's it. Alright. Now to figure out the a, we want to plug in a point on the parabola. So if I look at this point right here on the parabola, it says the height is 10 and is 20 feet wide all the way across. So it's 20 feet wide all the way across from the y-axis to this part. That's going to be 10 feet. So this point right here is 10, 10. Right? 10 high and 10 across. Okay, so if I plug that point in there, then we get 10 is 8 times 10 squared. 10 equals 100a. So a is going to be 10 over 100, which is 0.1. Okay? So we have the equation of our parabola is y equals 0.1x squared. Okay. So this is useful because now it's asking us how wide is the surface area of the water when the water depth is 5 feet. Okay, so water depth is 5 feet. That means that the y value is 5, and we're trying to figure out how the width of the surface area, so we can find half of it by figuring out the x value. So we're going to plug in y equals 5. We get y equals 0.1 times 5 squared. 0.1 times 25, this gives me 2.5 feet. Multiply that by 2 times 2 to get 5 feet. And that's all the way across. So that's how wide the water and the level of the water is. Alright, there we go. Alright, so let's look at this next example. Modeling using quadratic function. So in this figure, it shows a ball is located on the edge of a cliff right here. The ball is kicked and its height in feet above the level is given by the function y of t equals negative 16t squared plus 48t plus 50. T represents the seconds elapsed after kicking the ball. What is the maximum height of the ball when it hits, and when is this height achieved? When does the ball hit the ground? How high is the cliff? Alright. So let's impose a coordinate system. Okay, so let's have our y-axis go here and our x-axis go here at the ground level. So my origin is right there. Okay, so again, you have choices of where to impose your coordinate system. This is my choice. So this is so this is like horizontal distance, this is vertical distance, okay? But actually what we're interested in the height as a function of time. Okay, so y of t is equals to negative 16t squared plus 48t plus 50. So we actually want a different type of coordinate system. So instead of looking at like horizontal distance and vertical distance, we want to look at y as a function of time. Okay? And we can see that this is also a parabola. So when t is 0, the height of the ball is going to be at 50. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So let's make this 50. Okay, so this is when t is 0, that's how high the ball is. And then it's going to go up, and then it's going to hit the ground. So it looks the same, right? But I want to have it, you know, t to be my horizontal axis and height to be my vertical axis, alright? So the first question is, what is the maximum height of the ball and when? Okay, so the maximum is achieved at the vertex. Okay, so we need to find the coordinates of the vertex to answer that question. Okay, anytime you have like in a parabola, if it's asking you for a maximum or minimum value, that's code work for find the vertex. Okay, so the vertex is given by negative b over 2a. Right, so here a is negative 16, b is 48. So we have negative of negative 16, negative 48. Sorry, I'm messing up my numbers. The vacuuming is distracting me. I have no control over it. And then 2 times negative 16. So we have negative 48 over 32. That gives me 1.5. Alright, so this 1.5 represents the seconds, how long it took the ball to reach that maximum height. Okay, so let's say we have this is 1 and this is 2. 1.5 is how long it took to reach that maximum height. Now if we plug this into our y, so plug in for t, that will give us the maximum height. So negative 16, 1.5 squared plus 48 times 1.5 plus 50. Alright, plug that in our calculator. And then this gives us 86 feet. Alright, so this is 86 feet is the maximum height. Alright, so this is some of our answers. This is when, and this is how high. Alright? Now the next question, when does the ball hit the ground and how high is the cliff? So the ball hits the ground when the height is 0. Okay, so you plug in y is 0. So 0 equals negative 16t squared plus 48t plus 50. And we can solve that quadratic equation. Let's divide everything by negative 16 just to have smaller numbers. So we have 0 is t squared minus 3t. 50 divided by 16 gives me minus 3.125. Negative b plus or minus b squared minus 4ac over 2a. We get 3 plus or minus 3 squared, which is 9, minus 4 times 1 times negative 3.125, divided by 2. I'm going to do the square root bit. Square root of 9 plus 4 times 3.125. 3 plus or minus 4.64 divided by 2. Alright, so this is just a random mark. Okay. So 3 plus 4.64 divided by 2 is 3.82 seconds, and 3 minus 4.64 divided by 2, negative 0.82 seconds. Okay, so we take the positive time. So this tells me right here is at 3.82 seconds. So that's how long it took to hit the ground. Okay, last question, how high is the cliff? That's when t is 0. Okay, so when at the time is 0, it's the ball starts at the top of the cliff. When t is 0, it's the height equals to 50. So y at 0, you get 50 feet, and this is how high the cliff is. Alright, cool. Alright, let's look at this next applications of quadratic functions. So a hot air balloon takes off from the edge of a mountain lake. So right here. So here's the lake, and sort of this is kind of as the mountain is sloping up, alright? So we impose the coordinate system as shown in this picture, and the path of the balloon is given by this quadratic function, negative 2 over 250 to 2500x squared plus 4 over 5x. So that's just sort of given to us. The land rises at a constant incline from the lake at the rate of 2 vertical feet for each 20 horizontal feet. So that's the slope of that incline. What is the maximum height of the balloon above the lake level? Alright, so that question is like above the lake level, you basically, what's the maximum height above that axis? Alright? So that's code work for where the vertex is. Alright, so let's find the vertex. So we have our function is y is negative 2 over 2500 x squared plus 4 over 5x. So notice that in this case the quadratic equation that we're given is like how the vertical height as a function of the horizontal height, not of time. Okay, so we're looking at that relationship now. Okay, so we're placing the balloon in space, not with sort of at what time. It's like what location in space it's sort of the maximum occurs. Okay, so we find the vertex. So x equals negative b over 2a. So b is 4 over 5, so we have negative 4 over 5 divided by 2 times negative 2 over 2500. Just use your calculator to find it, or you can simplify by hand. Negative 4 over 5 divided by 2 times negative 2 divided by 2500. And I get x is 500. Okay, so when x equals 500, that vertex happens. The height is going to be the y value of the vertex, so plug this back in. So negative 2 over 2500 times 500 squared plus 4/5 times 500. Again, just use your calculator. Negative 2 divided by 2500. times 500 squared plus 4 over 5 times 500, and we get y equals 200. Okay, and that you can you can read that from the picture too. So that's the maximum height, and that's how far away straight from the lake. Okay, so this is the height above the lake level. The next question is, what is the maximum height of the balloon above ground level? So now we're looking at this height right here. Alright, so we got to figure out, as with the slope of the incline that we're given, how high did the ground go up? Alright, so let's look at the equation of that line. So equation of line. Okay, so we're told that it goes up, so the slope is going to be 2 vertical feet per 20 horizontal feet, 1 over 10, or 0.1. Okay, so y equals mx plus b is going to be y equals 0.1x, and the b is 0 because it's starting at the origin. So that's the equation of that line. Alright, so when the vertex happens for the balloon, the x value is 500. Okay, so if we plug in x equals 500, we get the y value of the ground is 0.1 times 500, which is 50 feet. Right. So this bit right here is 50 feet. So to find the difference, right, to find the height with respect to the ground, then we're going to do the 200 minus 50, and we get 150 feet. So the balloon is 150 feet above the ground. Alright. Where does the balloon land on the ground? Okay, so now we're looking at here. So question is, where is the parabola intersecting the straight line? So we want to take this equation and this equation and plug them into each other to figure out where they intersect. Okay? So we're going to have 0.1x equals negative 2 over 2500 x squared plus 4 over 5x. 0 is negative 2 over 2500 x squared plus, let's see, 4/5 minus 0.1 gives me 0.7 x. We can factor this. 0 is x times negative 2 over 2500 x plus 0.7. We get x is 0, which is this intersection point. And then we get negative 2 over 2500 x plus 0.7 equal to 0. And when we solve that, we have 0.7 divided by 2 divided by 2500. We get 875 feet. Right? So this right here is an x value of 875 feet. Right? Do we need the y value? Where does the balloon land on the ground? Yeah, let's find the coordinate points. So the y value is going to be 0.1 times 875, which is 87.5 feet. Okay, so 875, 87.5, that's the coordinate point where the balloon is landing. We can also express this like as a distance, if we can find this distance along the ground. If we use the distance formula, square root of 875 squared plus 87.5 squared. That's like if you're driving or you're walking and you want to meet the balloon, that's how far you walked. So square root of 875 squared plus 87.5 squared, 879.4 feet. So that's kind of the distance along the ground that somebody is walking. Probably not driving. Right? All right, let's see. Last question. Where is the balloon 50 feet above the ground? Okay, so it's going to be in two places. Here, actually not there, just there. Oh no, 50 feet above the ground. Ooh, interesting. Okay. All right, so not above the water, above the ground. Okay, so basically it's like we need to do here is, so we want the difference between the parabola and the line to be 50 feet. So it's kind of like a place where the difference between these is 50 and probably another place here. Okay, so what we need to do here is we need to subtract the parabola and the line, and that difference needs to be 50. Okay, so let's do that. So we have the equation of the parabola, which is -2 over 2500 x squared plus 4/5 x minus the line, minus 0.1 x, that needs to be 50 feet. Okay, so that's what we're solving. This is the 4. Alright, so we have, what is 2 over 2500? I probably should have done that a long time ago. -0.0008 x squared plus 4/5, so 0.8 minus 0.1, 0.7 x minus 50 equals 0. Let's divide everything by -0.008. So we get x squared minus 875 x plus 10,000 equals 0. Okay? Quadratic formula, 875 plus or minus square root of 875 squared minus 4 times 10,000 divided by 2. I'm going to do the square root part. 875 squared minus 4 times 10,000. 1, 2, 3, 4, 5. And we get 875 plus or minus 851.8 divided by 2. Solve both parts. So 875 plus 851.8 divided by 2 is 863.4 feet. And the other one, 875 minus 851.8 divided by 2, is going to be 11.6 feet. Alright, so those are the two locations where the balloon is 50 feet above the ground. So this is the lower value, the 11.6 feet, and then 863.4 feet is, yeah, somewhere around here, like there. Alright, so two locations you can kind of think of, sort of, this is like 50 feet above the ground, and then you're trying to figure out where the balloon is at those points. Alright, that's it for that problem. Alright, let's look at one more application problem. This time financial application. So assume the value of a particular house in Seattle has increased in value according to a quadratic equation y equals b of x, where the units of y are in dollars and x is represent the number of years the property has been owned. Suppose the house was purchased in the year in January 1st, 1970, and it was valued at $50,000. Okay, so let's make a little table of values. So value of X. So it was purchased in, let's call that 0. All right. So January 1st, 1970 is it's year 0. So this is when X equals 0. Okay. And the value was $50,000. In 1980, the value of the house on January 1st, so that's like 10 years from, so January 1st, 1980, this is 10 years from then. Okay, so it was $80,000. Finally, January 1st, 1990, this is 20 years after, the value is $200,000. Okay, you can see that this is not a linear growth, because in the first 10 years it goes 30,000, but then in the next 10 years it goes 120,000. So definitely, you know, not a linear growth. And then find the value of the function on January 1st, 1996. So January 1st, 1996, this is going to be, X is 26, so 26 years down the line. And then find the value of the, when the value will be valued at 10 million. Okay, so first we got to figure out, a million, sorry, what this is according to this pattern, and then we need to figure out when it will reach 1 million. Okay, so we got to figure out what this equation is. So we're told it's a quadratic function. We're told that this is going to be ax squared plus bx plus c. Alright? We don't know the vertex, so it's not useful to have the vertex formula. We have like 3 coordinate points. These are like x and y values. Right? So we know that when x is 0, y is 50,000. Right? So we're going to plug that in. We're going to say that 50,000 equals a times 0 squared plus b times 0 plus c. So these cancel out. C equals 50,000. Right, so that finds the y-intercept basically. We know that when x is 10, this is 80,000. So we plug those numbers in. So 80,000 equals ax squared, so a times 10 squared, plus b times 10, plus c, which we know is 50,000. Alright, subtract 50,000 from both sides, so we get 30,000 equals 100a plus 10b. Let's divide everything by 10. So we have 3,000 equals 10a plus b. Alright? We can't solve for a or b. We're going to solve this equation and move on. Okay? So here we found c. But here, because a and b are together, we can't solve yet. But we have another point. We're going to plug that point in too. So 20 and 200,000. So we have 200,000 equals a times 20 squared plus b times 20 plus 50,000. Subtract 50,000 from both sides, so we get 150,000 equals 400a plus 20b. Divide everything by 20. So we have 150,000 divided by 20 is 7,500 equals 20a plus b. Okay, so we have another equation for a and b. Okay, now we can solve these. We can pair these up because they both have b in it. Alright, we can solve for b here. So b is going to be 7,500. There's an a here. 7,500 minus 20a, and then plug it into b here. Okay, so we have 3,000 equals 10a plus 7,500 minus 20a. Let's subtract 7,500, so we have negative 4,500 equals negative 10a. So divided by 10a is going to be 450. Right? Plug back into here. B is going to be 7,500 minus 20 times 450. So B is going to be 7,500 minus 20 times 450 is going to be negative 1,500. Alright, so we found our A and B and C. Okay, and we put it in here. Basically, this finds the equation of that quadratic model. Okay, alright, so y is going to be 450x squared minus 1,500x plus 5,000. Alright, there we go. Okay, so this tells you, this lets you calculate the house prices. Okay, so you can check, right? You can check for the numbers that you already have, the x is 0, and x is 10, and x is 20, right? If I plug in x is 0, I'm going to get 50,000. If you plug in x is 10, hopefully you get the value that you were given, which is 80,000. Okay, I'm just going to do that on my calculator. 450 times 20 squared minus 1,500 times 20 plus 50,000. And I got 200,000. Oh, that's because I plugged in 20. 200,000. Alright, good. If I plug in 10, I get 450 times 10 squared minus 1,500 times 10 plus 50,000. We get 80,000. Good, so this kind of verifies that we got the right thing. Alright, so now the question is, what's determined to predict the house prices in the year 1996 when x is, in 1996, x is going to be 26. So you're going to plug in 26 in both. So we have 450 times 26 squared minus 1,500 times 26 plus 50,000, which is 315,200. Alright, now the other question is like, when is the house going to be a million? So plug in a million for y. 450x squared minus 1,500 x plus 50,000. So this is a quadratic equation that we need to solve. Subtract the million from both sides. So 0 is 450x squared minus 1,500x minus 50,000 minus a million is negative 950,000. 950,000. I'm going to divide everything by 450 to make my numbers smaller. 0 is x squared minus 1,500 divided by 450. 3 1/3. And then 950,000 divided by 450. It's 2111.1 repeating. Alright, so quadratic formula, we get negative b plus or minus b squared minus 4ac divided by 2a. 3.33 repeating plus or minus 3.33 repeating squared minus 4 times 2111 repeating times 1 divided by 2. Alright, so we have, we're going to do the square root. Let's see, 3 1/3, so we have 3 squared minus 4 times this is a negative. So that should end up being added. So negative 2,111.111. I'll put as many ones as possible. There we go. So 3.3 repeating plus or minus 91.95 divided by 2. So let's do, so 3.33333 plus 91.95 divided by 2. We get 47.64. And then the other number is negative, which we're looking at years, right? So we don't need to do that. So this is the time since 1970. So the year is going to be 1970 plus 47.64. So it's 2017.64. So you can round it up to 2018. So somewhere in the middle of 2017 is going to reach $1 million. All right, let's go. All right, so let me, before finishing, I showed you how to do all this by hand with the house prices. There's a way to use Desmos, to use technology to do the calculations for you. Obviously, it's good to be able to do this by hand, but it's also good to know how to use the technology because often this is sort of the most time-consuming part of math, right? So to use Desmos to find the equation. So if you know that your model is quadratic, you know that the equation has to be ax squared plus bx plus c, and you're told that it's a quadratic function, and you're given some data. You can put this data into Desmos and let Desmos find the equation for you. So the way you put the data into Desmos, you're going to hit the plus, and you're going to do the table. Okay, so you can see x and y columns here, x1, y1. So you put your x values, 0, 10, and 20. Those are the data that's given, 0, 10, and 20. And you're going to put the y values, 50,000, 80,000, 200,000. 50,000, 80,000, 200,000. All right. So here we're not so much concerned about the graph, but we can look at the graph. Mainly we just want to find the equation. So let me see if I can shrink this a little bit. And you can see the graph a little bit. Right now we don't see anything on the graph because our scales are not right. All right, so x needs to go from about 0 to 20 and y needs to go from about 0 to 1,000,000 or something. Okay, so let's set this up. So let's have x go from 0 to 20, maybe to 30. And then we want y to go 0 to 1,000,000. Or 200,000, or 50,000. We just have 1,000,000. Actually, let's have 300,000 for now. We can change it later. Okay, good. All right. So you can see our points. Okay, you can kind of see that it does look like the 3 points in a parabola. All right. So now to find the equation, you click on the next line in Desmos and you're going to type the following. You're going to say y sub 1. You can find the subscript either by doing shift and dash, or you can use your keyboard. Okay, so you can do subscripts on the keyboard. How do you do subscripts on the keyboard? Huh, I don't see the subscript on the keyboard. I think what I do is just use the shift key and then the underscore, which is like next to the 0 on your keyboard. Right? So you do y sub 1 and you do squiggle. So this is shift and then it's sort of the key right next to the number 1 on the top, right? And then we do ax sub 1 squared plus bx sub 1 plus c. Okay, so you need to have the subscripts, the y sub 1, x sub 1, x sub 1. Okay, so type in exactly what I type here. So what it's going to give is it's going to give the a, the b, and the c. So a is 450, b is 1500, and c is 50,000. And this is what we found by doing it by hand. Okay, so Desmos does all those calculations like less than a second. Okay, so let's see. Okay, so here's sort of the parabola, the graph of the parabola, and you can see that it's going through all the points that you put in. So these are the original points in the graph, and the parabola, the function models that data, models the points. It means that it is going through those 3 points. All right, so now if I want to do predictions, then you can use the graph, right? So when it says what is the house price for x is 26, then you're going to go to the graph when x is 26. Let's find x is 26. There you go. So it's 315 and 200. So that's what we got when we plugged in. And the other question is like, when will the house be $1 million? You can go to 1 million here and you click on the graph and you get the answer is, let's kind of click on until we get to 1 million. It's not quite, like it can't click too much. Let's see if we do y equals 1 million. There you go. It finds the intersection point, and you can see a 47.6, which is what we found by hand. So yeah, Desmos is great. So kind of use it a lot because it will help you check if your answer is correct. It helps you do these calculations a lot quicker. All right, so that's it for problems in this for this problem set.